Hey guys, Mr. Murray. Just touching base on chapter 2. Chapter 2 isn't horrible, just a little bit of chemistry that we need to talk about as my daughter is dancing in the background, trying to distract me. So, a couple things as we kind of flip through the chapter. Make sure you're hitting these case studies. This one's on page 32. The other thing we need to spend a little bit of time is this idea of a mass number, an atomic number, and sort of how do we figure out our protons, neutrons, and electrons. That's a P. Sorry about that. And so we'll just spend a minute with this. Keep in mind, like we can have an atom. Of course, so we have these things called elements. We have these things called elements. Here we go. Elements are going to be, and this is not working too well right now. Elements are going to be groups of atoms, okay, that are all the same type of atom, okay? So that's what an element is. Okay, so when I walk to the store, I buy myself some sodium metal. Well, that sodium metal is going to have all those elements of sodium will be in that little package of sodium, right? So inside of that sodium, right, I'm going to find what? Well, I'm going to find all those little atoms. And there we go. All those little atoms. And all those atoms are going to have in them 11 protons. This is some of the characteristics of sodium. They're going to have 11 electrons. And I think they're going to have something like 12 neutrons. Every single one of those atoms that you see, right? All right, grand. Real quick, the atoms that we're talking about, those remember, neutrons we'll find in the nucleus. The protons we'll find in the nucleus. And the electrons are found outside of the nucleus, just going in orbiting these things called energy levels. Of course, this is all chemistry from last year, so you can take a look back at your chemistry notes. But real quick, in terms of like a problem you might see with this, you would see, all right, well, if I know my mass number of something is, let's pick one. Pencil's not really loving me right now. Let's say my mass number of an element is, we'll just stick with the sodium because it's right here, is 23. If that mass number is 23, I know because I said it was sodium that it's going to have 11 protons. So it must, therefore, do a little math, right? This is the mass, and protons and neutrons have protons and neutrons have mass. Okay, so if 11 of those mass values or atomic mass units are because of protons, then I do a little subtracting, and I must have 12 neutrons, because that's the only other thing that has any significant mass. If I said it was a sodium atom, it's going to also have, because I said the word atom, and atoms have an equal charge. They have no net charge, in other words, so the protons equal the neutrons inside of atoms. So if I said that it was an atom, then you could infer, you could just understand that it must have the same amount of protons as neutrons, and because it's sodium, it has 11 protons. Oops, I lied to you. Hang on, scratch that off. That was a mistake. In an atom, the protons equal electrons. Sorry. So if I said it was an atom, magic word here, then I know the protons equal 11 electrons, and so it must have 11 electrons as well. Okay. All right, that sort of does it for that atom stuff. Understand that those atoms have, of course, a nucleus, and then the electrons are out here in these energy levels. And one of the things we learned about atoms is that these electrons can get excited by light. As they get excited, they move to higher energy levels, and then they fall back down. They can get excited by light, they can get excited by heat, they can get excited by any number of things. And when they fall back down, what they're going to do is they're going to emit light, okay? And so part of what we know about those energy levels is because of the color of that light that gets emitted. Ooh, come on. You guys proud of me for that color thing? Okay. All right. We're not going to stress too much about the shapes of those shells. You have s orbitals, you have p orbitals, you have d orbitals, you have f orbitals. I think it is the last one. We don't stress about what those orbitals are. Okay, that's going to keep you up at night. Okay. What you do want to spend some time with is, how do atoms become stable? And they're going to become stable in two basic ways. They're going to gain or lose. That's one way for them to become stable. Or they're going to share. And what we're talking about sharing and gaining and losing is the electrons. Okay, so when we look at our periodic table, here's our table. It does something like this. Okay, right over here we have these things called the noble gases. And the noble gases have a stable outer shell. They have what's called a full octet. Okay. So effectively what you need to know in chemistry is that everyone who's over here wants to be like those nobles. Okay. Now everyone that's over here also wants to be like those nobles. So what they're going to do is they're going to either gain, lose, or share electrons to be like these nobles. What am I saying when I say that? Well, I'm going to say that they're going to do what they can to fill the outer energy level, or the valence shell. This is what you learned in chemistry last year. All right, so we'll do the gain share thing, gain lose thing. Let's say I have lithium. Here it is. I think it's here. Yeah, lithium is number 3. Because it's 3, it has 3 protons. Because it's an atom, it also has 3 electrons. But when we look at lithium on that table, it's way over here. Okay, this is where it is, which means it does not have a full valence shell. Okay, we're going to just do a quick model of it. Here it is. There's its nucleus. It has 2 electrons in that first shell, or first energy level. It has 1 electron in the next level. And so this electron's kind of hanging out all by itself. We don't know what to do with it, and it's all freaking out. And so what's going to happen with this electron is going to get lost. Because it gets lost, is that person still here?
Yeah, that's right. He wants to go back.
Because it gets lost, it leaves this inner shell here, which is our valence, which becomes our valence shell because this electron's no longer around. And because if that one's gone, it has a full valence shell, and so because this is the lower shell, this is now stable. But we still have that issue because we lost an electron. Now we have 2 electrons. And so what happens with lithium is it becomes an ion with a +1 charge. Why does it have a +1 charge, Mr. Murray? Well, we just went from 3 electrons to 2. We still have our protons here. And so what happens? Well, we have a 3 plus and a 2 minus. And that gives us a +1 charge for the lithium ion. All right, why is it an ion, Mr. Murray? Oh, well, it's an ion because the protons equal not the electrons. Are you guys good?
Yeah.
All right, so there's the ion story. I could also do this. I'm going to have you guys do this right now with, let's pick one. Do fluorine for me. Tell me what would happen with fluorine. Keep in mind it's going to have 7. It's very close to getting that full 8. And those shell numbers, just for giggles, are going to be 2, 8, 8, and then that'll be enough for us in biology. All right, so the next thing that can happen to get that full outer energy level, we'll mess with some carbon here, is that atoms can share electrons to get that full outer shell. So this is carbon's outer shell right now. I didn't really bother showing you its inner shell. Inner shell would have 2 electrons, and so I just drew those 4 outer electrons. Okay, the reason it has 2 and 4 is that carbon's atomic number is 6. It has 6 protons. If it has 6 protons, the atom must have 6 electrons. You'll notice I'm using those words very carefully. I said atom. So the atom of carbon is going to have 6 protons and 6 electrons. It has 2 in the inner level, and so it has 4 in this outer level. Here they are, 1, 2, 3, 4. So what's it going to do? It wants a full outer shell, and so it's going to, in this case, it's going to become a sharer. So it's going to share electrons in that valence shell. So let's show that again with a carbon. We're only going to focus on its outer electrons right now. Hey, so can you let Lulu out? Sorry guys, a little break there. So here's carbon sharing some electrons with hydrogen. Well, hydrogen's story is this. Hydrogen has 1 electron in its valence shell. And so what's going to happen is this. Carbon and hydrogen are going to share those electrons. Another hydrogen is going to come along, and it's going to bring its electron. Those electrons will be shared. Another hydrogen is going to come along. These electrons will be shared. Another hydrogen is going to come along, and it will share its electrons with carbon. So what do we got out of this? Well, if we're looking at our carbon, carbon's going to get a good deal out of this. It's going to get these electrons that it's been sharing. It gets to count them that it's been sharing with hydrogen. What does hydrogen get out of the deal? Hydrogen gets, we're going to change colors, hydrogen's going to get these electrons. And if we look at those numbers now, hydrogen gets to count this one and this one. And so hydrogen now has 2 electrons in its outer shell, as does this hydrogen and this hydrogen and this hydrogen. So hydrogen's all good. Okay. Carbon also gets to count those same electrons, carbon we had for green. So carbon gets this one and 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 this one. So carbon all of a sudden went from 4 electrons to 8. So carbon is also good. And this is what we call sharing of electrons. And sharing electrons is also known as covalent bonding. What? Okay. So covalent bonding is when atoms are sharing electrons, okay? So the question, so they're bonded, right? So one of the things that bothered me as we talked about this, like a lot of kids will memorize, hey, well, they're sharing electrons, so they have to be together. Well, you and your brother or your sister might share a car. That doesn't mean you want to hang out with each other. And so we got to get at that idea of the bond piece. So if we have an atom here, it has a nucleus, and we have an atom here and it has a nucleus, the question becomes, why are they coming together? Okay, and so the nucleus has in it, we know, protons, and so the nucleus is going to have a positive charge. If those electrons are being shared, then most of the time the electrons are going to be between these 2 atoms, and so what's going to happen is the nuclei with a positive charge are going to be attracted to the electrons that they share, because those electrons, again, are in this area most often. Of course, they're moving really fast, but most of the time they're in the middle. That gets us the shared. That gets us a covalent bond. Ionic bonds, you'll have 2 ions. You'll have lithium and you'll have oxygen, perhaps. If this has a -2 charge and this has a +1 charge, well, these will, of course, be attracted to each other because the opposites attract. The Pauli-Abdul principle from the 80s. All right, so that's the sharing thing. We'll do 2 more kinds of bonds. One is with it, we gotta get at the sharing a little bit more with water. Water has a good story. Actually, I'm gonna come back to water and V separ. the valence shell electron pair repulsion theory, and I'm going to come